Here's pre-calc. It's closure problem 4-128, and it says sketch this function, and that's just a square root function, and then approximate the area under the curve in the interval between 5 and 8 by both using 6. So I need 6 right endpoint rectangles and 6 left endpoint rectangles. And I have to write both of the sums using sigma notation. So I need, well, first of all, I actually I was going to just do it all on paper on a graph. So I got some graph paper out. And then I know that this thing is just a root function. Like this is just y equals square root x looks like this. That's the parent function. But this is x minus 3 plus 4, so it's going to be moved to the right by 3 and up by 4. So I drew a graph, but you can't see it very well, it's so ugly. And then I went 1, 2, 3, 1, 2, 3, 4. And then I was going to start like drawing my root function. And then I realized 1, 2, 3, 4, 5. Like this little interval is pretty small, and I realized it was going to be kind of hard to, I wasn't going to be looking at my grid lines to get my y values. So I went ahead and started up a table. So I'll draw that a lot nicer for you. I want to tell you though, before I start drawing a table, that I've seen some of you go ahead and go on Desmos, like to get, well, first of all, let's start the table, and I'll show you how it's kind of a little bit tedious. We're going to draw our table, and then I'll show you, I think, what might be an easier way by using a little bit of Desmos. So remember, we're just trying to find, oh yeah, how many rectangles do we need? 6, right? They told me I need 6 rectangles. So between 5 and 8, there's 1, 2, there's 3, like 8 minus 5 is 3. And then I need 6 rectangles though. So if I just count up by a half, like 5, 5 and a half, 6, 6 and a half, 7, 7 and a half, 8, that gives me my rectangles. But when I started trying to draw them, I saw how it wasn't going to be a useful drawing, because I'm still going to have to do the calculations. So I just made this little sketch. But anyway, my intervals are going to be 0.5, like the length of them, because I have 3 divided by 6 intervals, that they're going to be a half. Hopefully that makes sense. So I have to start at 5 and keep going up to 8. So I'm going to go 5, and then 5 and a half, 6, 6 and a half, 7, 7 and a half, 8. So this would be my left endpoint. Maybe I'll just make a rough sketch of it. This is just like my super rough sketch. My left endpoint rectangles are going to start at 5. So I'm going to pick these ones. These values will be for my left endpoint. And then my right endpoint rectangles are actually going to go, they're going to use the 8. And so they're going to be these ones. 6, 2, 3, 4, 5, 6. I don't know if that makes sense to you, but all I have to do is get the y values for these, and that'll give me the heights of the rectangles. And then I can add those heights together and multiply by a half, because they're just rectangles. Like, let's find this one's height. How would I find the height of this its little width is 0.5, this little tiny rectangle. Its height is going to be found by plugging 5 in to this function. So 4 plus the square root of 5 minus 3. So 4 plus square root 2, because 5 minus 3. So that ended up being, I already did all this, 5.41. And then when I plug in 5.5, I went 4 plus 5.5 minus 3. I pushed all the buttons on my calculator, and I got 5.58. And I'll go ahead and write all these numbers down. When I plugged in a 6, I got, and 6.5 gave me, and 7 gave me a 6. 7.5 gave me, and 8 gave me 6.23. Okay, so these are all the values. They're the heights. But I think I've seen somebody before just go up to Desmos and just graph this thing. So we can just go y equals 4 plus, I'm not sure if I'm going to actually be able to do this, square root x minus 3. Let's find the square root. So there's the one that is kind of a lot nicer looking than mine. And then if I want to, I think I can find some values. Like, remember I was just trying to calculate the value for when x is 5. I can just, 5 gives me 5.41. So check this on your, if you already wrote down your table. 5.5, whoa, 5.5 gives me 5.581. I can write these all down on my table. 6, see how you can do that? 6 gives me 5.732. And it doesn't even say that you have to have a table, but that's how I do it. So I'm going to go back to, so I could have gotten these values by just tracing along in Desmos and writing down the y values if I wanted them. And then all I would have to do is add these ones together and multiply it by a half, and that would actually give me my left endpoint. I'll just write left. And those turned out to be 17.36. And then if I want my right endpoint triangles, or why do I say triangles? Rectangles, I'm going to take these values. And so I would add them all up, like I put in my calculator, 5.58 plus 5.73 plus that plus that plus that plus that. And then I'm going to times it by a half, because you know how like the area of a rectangle is length times width? The width of each of these little rectangles is a half. I didn't draw them all in there because I was lazy, but each rectangle is a half. So the right endpoint triangles turned out to be 17.77-ish. So these are the two areas right here. I'll write units. Actually, they're square units. I'll write a little square on them. But I did this all by hand, and then it asked me to get the summation notation. So I know that the summation notation, I actually did mine starting from 1, but in this video I'm going to start from 0. I'm going to start from 0, and for left endpoints, I'm going to start from 0. So basically I want these values, 1, 2, 3, 4, 5, 6. I want these 6 values. And I want them to go, so this will be 0, 1, 2, 3, 4, 5. Whatever they add up to, I'm going to multiply it by 0.5 because that's the length of the rectangles. And the way that I got these numbers is I plugged x's in up here to this. So I am going to have a 4 plus, and then x, The x's are all going to be in terms of n. Okay, so maybe the hard part is finding out what the x's are. So I know my first x is 5. And I know that the x's go up by 0.5 each time. Like I'm adding 0.5. And this is going to be something linear, like y equals mx plus b. So I'm trying to find a y equals mx plus b that starts me out with 5. Oh, so b is going to be 5. Let's see, let's write that down. Hey, and the slope's going to be 0.5. I should have wrote n, 0.5x plus 5. Now let's see if that really gives me what I need. 0.5 times the 0th term is going to give me 0 plus 5. That gives me my 5. 0.5 times the first term would just give me 0.5, and then it's going to add 5. So that would give me my 5.5. 0.5 times the second term, well, that would give me 1 plus 5. That gives me 6. So if you want to check those, this is actually going to work. So 0.5x plus 5. So if you want to make that a little nicer to type into Desmos, you could just go, we got the 5 and the minus 3. So we could say it's 0.5x, what's 5 minus 3, plus 2. Okay, I'm going to type that into Desmos. Or wait, well, you don't have to. It didn't ask you to, but I'll show you at the end. So here's my notation that I want to use for the, this will be left endpoint. 0.5 as n goes from 0 to 5 of 4 plus. So this is part of your answer when it asks you for the summation notation, and then the right is going to be kind of just like it, but you're going to use, you know how you don't use that top number, you use this number. So you're going to start your n from 1 and go to 6. Now, I'm not saying this is the only way to do it, because I did it a different way when we were working in class. I started from 1 and went to, well, anyway, I started it a different way, and it still worked. So these are the answers they're looking for summation notation, and these are the areas that they're looking for. And let me show you on Desmos. On Desmos, you can type. I put my 0.5 here, but you can also, oh, did I forget the point? No, I got it. You can put the 0.5 out front or over here. But this says it's going to add, oh, do I have stuff wrong? Here, let's do it this way. I'm going to go from 0 to 5. And I think I see a mistake now. I think this was left over from when I was doing something else. So this is our formula that we had, our little, does this match? Yeah, 5.36, or sorry, 17.36. Okay, so this should match our area. See how the Desmos does it for you. And then if I go from 1 to 6, go from 1 up to 6.